Hello, Bridge. How are you doing? It's week 4. It's the second assignment. It's the second assignment that should say 4.2. Good catch, Miss Blackman. Okay, I got a bridge of the day, and then we'll get rolling with this. Any guesses? Woohoo! It is the Imbaba Bridge in Cairo, Egypt. I'm probably not saying that right, but it looks pretty cool. Okay, so today we are going to look at solving exponential word problems. It's going to be the same thing that we did in the first assignment where you're going through the same steps. You're going to have to write it from exponential form to logarithm form and then evaluate using the change of base formula. But now we're just going to be inputting all of the information that we get into that form. Do you remember this form? We had like A equals P times 1 plus or minus R raised to the power of T. Again, I'm going to go through this real quick. A was like an amount after a time period, right? An amount after a certain time period. Usually we were using years if you were talking about finances and interest growing in a savings account. P is it's technically called, why we use P, it's technically called the principal. Principal, oh my gosh. We've been out of school too long, haven't we? The principal, or it's the initial deposit, initial amount. Okay. And then inside of this parentheses here, I have 1 plus or minus R. Again, R is our rate. It's a percentage as a decimal. Percentage as a decimal. And then T was a time period. Usually we were using years. If you were talking about banking. Today I've got a couple different time periods we'll look at. And then remember that inside this plus or minus depends on if you are doing a growth or decay problem. If you are talking about growth, if your problem is growing exponentially, maybe you're gaining interest, obviously then you're going to use 1 plus R. If you have something that's decreasing in value exponentially, or we use this fancy word called depreciate, then you would use 1 minus R. So this indicates you're going to be using growth or decay. That kind of tells you what you would be doing. Anyway, so my little steps here is just to input everything that you know from the word problem. And then just follow the same steps. You're going to have to use log. Basically what we're going to be doing is we're going to be solving for time, all right, in these problems. We're going to start off very simply, and then I'm going to put a little more trickier ones to it, but it'll be all right. I'd say take a second, read through it, try it on your own if you want. Population of bacteria starts with 2 cells. So as I'm reading this, I'm going to start highlighting things. It starts with 2 cells, so that sounds like my initial deposit. I'm going to say that's probably my p-value. Again, that little general form that we had, I'm going to write that up there. Okay, so starts with 2 cells, triples every hour, triples every hour. So that kind of sounds like a rate, right? Tripling every hour. I'm multiplying by 3 every time. So I'm going to say that's probably going to be my rate, or the inside part, right? Because it isn't a percentage necessarily, but I am multiplying by 3 every time. So that should indicate that I'd be doing like 3 to the power of T, right? And then it's asking how many hours until the bacteria population is 500 cells. Okay, so this might be something new. Previously, we inputted all the information we had into this side of the equation, right? But now we know something right over here, this how long will it take until it reaches 500 cells? Now we know some information about the left-hand side of the equation, right? This kind of end goal of 500 cells. So if I input that in, that's going to be like my end all amount. So that's going to be my A value. So I'm just going to write this all out. I'm just going to write this. There we go. Okay, so I'm going to input all those informations that I have. 500 cells, that's my end amount, right? That's kind of like my A value equals P, my initial value. I'm starting with 2 cells. And then, like I said, this rate, again, it's not a percentage, but I'm tripling every time. So I'm multiplying by 3 every time. So I'm going to put 3 on the inside here. And then raised to a power of T. Right, and this is time, and that's what we're trying to solve for. That's like our big question here is how many hours? What is the T value, right? So We've inputted everything. Now we're just trying to solve for this variable t. It's an exponential equation. We've done these before in our last assignment, so go ahead and solve. First, I want to get it to a very simple exponential basic equation, so I need to get rid of that 2, so I'm going to divide by 2 on both sides, and that leaves me with 250 equals 3 to the power of t. And then this is my simple basic exponential equation. Now I can take that and write it as a logarithm equation. So I see that I have a base of 3 raised to the power of t equals 250. So as a logarithm equation, this is going to be log base 3 of 250 equals t. Again, what power do I need to raise t to in order to get 250? That's what we're solving for up here, right? So now I have t equals log base 3 of 250. This part is something that I can actually solve for using the change of base formula. So I'm going to say that using my change of base formula, t has to be equal to log base 10 of 250 divided by log base 10 of 3. And again, we have base 10 on our calculator, so you can just type in log 250 divided by log 3, and that's going to get you a t value of about 5.0258. All right, so after about 5 hours, again, how many hours until the bacteria population is 500 cells? Well, it will be 500 cells in about 5 hours. All right, let's move on to the next one. Again, just inputting all the information we know and starting to solve an exponential, just like our last assignment. So I've got a equals p times 1 plus or minus r to the power of t. Abed deposits $150 into a savings account that gains interest at a rate of 5% every year. Okay, let's just pull out the important information that I have. Deposits 150 into a savings account. That sounds like my initial value. That's probably going to be my principal P. It gains interest at a rate of 5% every year. So there's my rate. Right now we're talking about percentages. So I'm going to have that rate. And let's just convert that percentage into a decimal right now. 5% as a decimal is 0.05. And then it says how many years until the balance is 200. Again, that's what we're trying to solve for. How many years? So we're trying to solve for that exponent of t until the balance is 200, right? And that's kind of my end-all, be-all goal here is this 200, right? That's what it should be after some amount of years. So now if I can input all of this into that formula, I can say 200 equals my p-value, or 150 times 1. Again, this is a exponential growth problem, so I'm going to use 1 plus r. So 1 plus my rate as a decimal, so the 0.05. And raised to the power of t. That's my exponential equation. Now I'm just going to start to solve. So first I can divide by 150 on both sides. Again, my goal is to get it to a very simple exponential equation. I have to do a little bit more simplifying. 200 divided by 150 is 1.33 repeating equals, and then 1 plus 0.05 is just 1.05 to the power of t. Now, it looks kind of crazy because there's decimals, but this is a simple exponential equation, right? Now I have my answer equals a base raised to an exponent. It's very easy for me to put all of this into logarithm form. So I'm going to put this as a log equation. So I have a base of 1.05, log base 1.05 of my answer over here, the 1.33. Repeating, equals my exponent t. And again, now I can use my change of base formula to evaluate what this side is. So I'm going to get that t equals, I can pick a new base of 10 again, so it works with our calculators. I'm going to say log base 10 of 1.333333 divided by log base 10 of 1.05. Again, you plug that into your calculator, however you do it with your change of base formula. Log of 1.33 divided by log of 1.05 gets me a t-value of about 5.8963. So it's roughly, I'm just going to call it roughly 6 years, okay? And I would highly encourage you to try it out by yourself. If you say, this is like time, and this is how much money I have in my account, after 0 years, I mean, just make a table and test it out, right? After 0 years, you should have 150. After 1 year, well, now I'm multiplying by 1.05 to get that next value. You will get 157.5. After 2 years, multiply by another 1.05, and you'll get 165.375. After 3 years, after 4, keep multiplying by 1.05. 5 and 6, does it check out that after about 6 years you have about $200? Trust me, I did it. It works, but try it out. Okay, I have one last one for you. It's another account problem because I think, you know, once we put things to dollars and cents, sometimes things just work. So anyway, I'm just going to rewrite this so we have it off to the side one more time. There you go. Okay, Troy deposits $1,000 into a savings account. Again, we have an initial value, so that's my p-value. Gains interest at a rate of 2% every month. So 2%, that's my rate, and 2% as a decimal. So off to the side, I'm saying 2% as a decimal is, I move that decimal place over twice, fill in that 0, so 2% as a decimal is 0.02. How many months until the balance doubles? Okay, how many months? So again, that's what we're solving for. That's our time period. How many months until the balance doubles? Now we're not given an end goal of, you know, $2,000 or $3,000 or $5,000. It just says how long until it doubles. So if my initial amount is $1,000, well, doubling $1,000 would give me $2,000. So now I know that my A value has to be equal to $2,000. Okay, so now let's just plug that all information that we got. What do we got? $2,000 equals my initial deposit of $1,000 times 1. This is a growth problem, so 1 plus my rate of 0.02 raised to the power of t, or I guess we could use m for how many months if we're gaining interest every month. I'm just going to keep it with t here, and then we can just start to solve. So again, I got to get this into a simple exponential equation. I'm going to divide by 1,000 on both sides, and that's going to give me 2 equals 1.02 raised to the power of t. And then, yes, that is a simple exponential equation. Now I can write it in logarithm form. So I have a base of 1.02, so I'm going to have log base 1.02 of 2 equals t. Using my change of base formula, I'm going to say that t equals log base 10 of 2 divided by log base 10 of 1.02. Again, plugging that into your calculator, I got a t-value of 35.0027. So it's roughly 35 months. And then I was thinking, oh, I wonder how many years that is. So I just divided by 12, 35.0027, yada, 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 divided by 12. It's roughly 3 years. Now the question asks for it in months, but it's about 3 years. So questions, let me know. Again, it's the same kind of stuff, but now you're just inputting all that you know, all the information that you're given into this formula that we're very used to, and then being able to solve your exponential using your logarithms and change of base formula. There will be a couple of problems very similar to this. I'll put a couple to like dollars and cents with some interest rates so you get that down, and then I'll start to throw in a little more complicated ones as we start rolling. Have a great day and go team.